actually just got done recording this video, and I wanted to put this in the beginning of the video just to say that this is going to be a little bit more of a technical type video, and wanted to show you guys kind of my thought process when I'm going through integrating something into the vehicle. So if you've seen the channel for a while, you've seen me do that a few times, where if there's a wiring project, I'll try to integrate things into the factory wiring as much as possible using existing relays, existing wiring. In this video, what I'm doing is integrating my trans brake and bump buttons into the factory steering wheel controls, like repurposing the cruise control buttons. So if you guys are like really intimidated by wiring, maybe this will help a little bit, trying to figure out how to trace down wires and figure out what goes where. Either that, or it's going to make you never want to touch a wire again in your life. So hopefully you make it to the end of the video. Let me know what you think and let me know where you ended up. Did it help, or are you never touching wires? Alrighty, well, this is my 1998 Ford Ranger twin turbo 5.3. It makes a smidge over 300 horsepower. I do have a trans brake on this truck, but I don't have bump set up yet. And right now I actually have my trans brake on the overdrive on-off button here on the shifter. So what I'm going to do is I think I'm going to move this button to be one of the steering wheel buttons. Oh, I didn't realize that's all loose. Hopefully that'll still work. But the idea is that I would have like on would be trans brake, and then I could use one of the other buttons for bump. I'm going to do that, try to tie everything into the factory wiring. And like aside from the wheels, everything is pretty stock looking on the outside. And aside from the seat and the roll cage, the dash and everything is pretty stock looking. All the factory gauges do work, but I do have the Terminator X dash here. I just have it kind of velcroed on. So to try to keep some of that factory look and not adding a bunch of random buttons or changing the steering wheel and having cords hanging everywhere, I'm going to try to use the factory buttons. So I know you guys have kind of seen me do this stuff a bunch of times where I try to integrate stuff into the factory wiring and stuff that's already there. What I'm going to be using is the multimeter, primarily with the continuity buzzer and maybe testing for voltage. Continuity buzzer meaning that if you have a connection, and the meter will actually beep, it'll give you a sound when they're connected. So where that can be helpful is when you're trying to find where a wire goes inside the car, you can hook up one wire, say to a plug in the engine bay, and then touch your lead on the inside of the car and it'll actually beep if it's the right wire or it's connected. Or if you're trying to find like a button functions through that circuit, you can push the button and it'll beep when it closes the circuit and try to help you find where that wire goes or if that's the right path. So I think that's why electricity can be kind of intimidating and wiring can be kind of intimidating for people sometimes because you can't really see what's going on. So a multimeter helps you see what's going on. Also going to be using this Holley solid state relay. I found this thing on Amazon. It does have the standard automotive relay layout, but it's wired a little bit differently. And this is like in the $30 to $40 range online. So a little bit cheaper than like the NOS solid state relay. So I'm going to try this thing and it'll connect to a regular automotive relay harness. Okay, well the first thing I need to do is disconnect all of my old wiring. So I have a positive going to the trans brake off of that button on the shifter, and it's split. That positive goes right to the trans brake solenoid and to my ECU. So I'll take you for a look into my dirty laundry here with some hidden wiring and stuff in my glove box. I do have just spare spark plugs and a spare wideband in my glove box. This is all CAN bus wiring, which I was doing some testing with and just kind of stuffed in there. So to get behind here, I'm going to open up my glove box and find my inputs and outputs that I have coming from the brake switch. So I have my white-blue wire, which is one of the inputs that goes to trigger the two-step. And what I need to do is separate those because now the wire that's going to the trans brake is going to go to that solid state relay, and now the wire that's going to the ECU triggering the two-step is going to come off of the trans brake button, which is an input to the ECU. So I got to separate those, so we'll do that. Alright, so taking a look in here, I have the ECU mounted on the firewall. I have this red wire now, which is marked brake, so that's the positive going down to the trans brake. And then I have my inputs and outputs just kind of bundled up right here. So I have two inputs remaining. I have my green and my red. I forget which inputs those are, but one of them is going to turn now into the bump input. I have this red-white wire, which actually comes from the button right here. I'll repurpose that one for brake, and then this white-blue I'll use for brake input. And then let's say I'll take that white-red, we'll pull that out. So I think I've kind of committed this truck to, because it's September already, so we're kind of almost close to end of the season anyways. So I've just kind of come to terms with the fact that I'm just going to wait till winter to rewire the truck, especially considering that I'm still like adding stuff here and there. I'd like to get everything kind of dialed into where I would want it before I do the final wiring. So everything's just kind of tossed in here. So I'll bring this red white out. So now I'll have brake input, bump input, and then I'm also going to have to use one of the outputs, one of the remaining outputs for a bump output, or brake output. Which I have my gray, black remaining, and all of the others are used. Alrighty, gentlemen, well, this is turning out to not be as smooth or straightforward as I thought it was going to be. One, partially because this little piece here is from the clock spring and this is broken, and I kind of forgot about that, but I noticed it as soon as I pulled the airbag off. This was tucked in a little bit more, but this piece was out here, and I want to say at some point, I wasn't thinking about it when I had the steering shaft disconnected, and I spun the steering wheel, and it just freewheeled around and then broke the clock spring. So the clock spring, if you don't know, is basically the electrical connection from anything on the steering wheel through the hub into the dash. So all the steering wheel buttons, the horn, everything goes through the clock spring. The airbags, all the electrical stuff. So one issue is my steering wheel button idea won't work because the clock spring's broken, which I'm just going to replace the clock spring. I actually went to the junkyard today and I pulled one, but I got there and I didn't have any cash or a card or anything to buy it. So I left it on the counter and I just left. So I do have one pulled, but it was from a 97 Explorer. I don't even know if that's going to work with the plugs in the dash. So I'm going to pull this one out, double check that that works. If not, I'll go back and I'll pull a different one. But the other challenge that I'm having is the buttons on the back side here. This is the button, on, off. The buttons actually have resistors in them for each of the buttons. So the positive signal comes in, and then, very hard to see, but this third pin up is like the feed to the button. It comes up over here, and you can see a little trace that goes over to the left 2 pins on this top button. The button is the 4-pin square there. So the left 2 pins are the feed, like the power source. The right 2 pins are powered when you push the button. And what that does is it sends power to this top pin through a resistor over here and then back out this pin 5. So because it goes through a resistor, it doesn't have like direct continuity when you push the button. So if I put this meter on the continuity buzzer and it beeps when I touch these together, instead of hearing something like that, so if I put this on resistance and touch the leads together, it shows 0 ohms, 0.1. So now if I put this on the 3rd pin and the 5th pin, and then I push the button, it's showing now 0.4. So it doesn't give me continuity. It does show, it recognizes that I'm pushing the button, but because of the resistor in there, it's still showing that I have resistance. And I don't think that that's going to be enough to actually send the ground signal to the ECU to activate the trans brake and the bump. So I'm not positive if that's going to work, but if I were to do something like this and go leads across the switch, it gives me continuity when I push the button. So what I can do there is just bypass this resistor. I can cut the resistor out, weld a wire into there, just solder over it. Basically just need to connect these 2 leads, and then I would have a button here. So I did look at the circuit, like I did kind of test all this stuff, and the other button is the exact same way. The only difference is if I'm counting pins from the bottom, this one is pins 3 and 5, and then the passenger side switch is pins 3 and 4 for the buttons I want to use. But something kind of strange here is this pin 5 and pin 7 are actually connected. So I thought that was really weird because one is connected when you push the on button for the cruise control, and then the other one is active and passes the ground when you push the horn sliders. So these horn sliders are grounded, and then when you push this button forward, it sends a ground signal out through what I'm calling pin 5. But then when you push the cruise control button, it sends a resistance-based positive out through pin 5. So the cruise control and the horn use the same pin, but one is a positive and one is a negative, and they're on the same wire. So that's kind of interesting. Alright, so again, using the continuity buzzer, I was able to kind of figure out through poking around in here what these things do, and by looking at the buttons. So the buttons all have one feed side. Like there's one wire that comes in that's a positive that comes in to feed all of the buttons. And the passenger side button has 3 separate buttons. So there's one feed that comes in, goes to all 3 buttons, and then each button has a resistance value that goes out. They're all different resistance values. So I think that's how the ECU or whatever is determining what it's going to do based on the resistance it's seeing from that circuit. So, alright, so I was able to figure out if I poke the bottom wire here, which I'm calling number 1, those have continuity. Number 2 has continuity. But then also if you poke number 1 here and number 2 here, those have continuity. So essentially on the bottom wire, those have continuity all the way through, all 3 plugs, and those are the power and the ground for the light on the button, because on both switches those go to the light, and then these are all connected. So these 2 button switches are connected to number 1 from the bottom and 2 from the bottom over here, which plugs into the clock spring. So now I know 1 on the bottom, 2 on the bottom, those are the bottom 2 pins here, and those are for the lights, power and ground coming in for the lights. And the other buttons all follow the same thing. So number 3 on this plug, 3 on this plug for the button, 3 on this plug for the button, are all connected to the 3rd pin up on the switches, which the 3rd pin feeds all of the buttons. So when we go on to pins 4 and 5, passenger side set Excel button is number 4 on this side, and then driver side on button is number 5 pin on this side. And those correlate to pin 4 and pin 5 on this plug that go through the clock spring. And to show that, I'll poke one lead in here, and then I can poke all these broken wires right there. So this wire, when I probe this one for the clock spring ribbon, that's connected to pin 5 inside here. Well, it's actually 4 or 5 because the probe's actually touching 2 of the wires. There you go. See, the probe's touching both of these. So I know that these wires are connected there, but normally this ribbon would be wound all the way up inside the clock spring, and it would go out through the wiring harness back that goes into the dash. So that's just kind of my thought process for how I'm tracing this stuff down, understanding what wires are going to do what, how I want to repurpose the wires, what I got to do to get the switches to work to send the signals that I need, and how I'm going to do it. So essentially, I'm really just going to be using pins 3, 4, and 5 in here. So when I bypass those resistors in the buttons, I'm essentially going to be using pin 3, which is a feed to the buttons, and then pin 4 is going to be out for brake, and pin 5 is going to be out for bump, or vice versa if I want to switch 4 and 5. So I did get the steering wheel out and the new clock spring from the junkyard. Here is the new clock spring. All of the spring is contained inside there now, so that works out. I did verify that the wiring is the same, and then I also did verify the wiring inside the 5 pins. So I have black, red, black, those are for the lights. Blue, black is going to be the button in, green, orange is bump out, yellow, green is brake out. And that's all the wires in here on this plug. This is for the airbag. This ground, this red, and this black here are going to be for the lights. And then this guy here goes in the key cylinder. And then these remaining 3 wires here are going to be for blue, black is going to be the button ground in. And then green, orange is going to be the bump out. And then the yellow, green is going to be the brake out. So I did Amazon special some new steering wheel wiring. So I got a new set of buttons with keypads and fresh wiring. The old ones were kind of crusty but not so trusty. So when I pulled them apart, they ended up just shredding because they're really like hard and brittle. And this one, you can see it's hard and it actually has a dimple in it. The button is actually up here, but it's got this big open area with nothing on the back side. And it's just all open on the back. So it just has a hole in it. You can see it's kind of cracked all the way around. So got new buttons and new wiring with some nice, fresh, soft rubber that's not going to rip. I did look at some of these on the junkyard too, and they're like all shredded. They're all really bad. But with the new buttons, the board inside them is completely different. These have LED lights on them instead of the old little bulb type light. Or maybe that's still an LED, but it's just, you know, not one of the big ones. That little tiny white speck is the LED. So I essentially had to go through and kind of retrace the circuitry on here. This one was a little bit different because the resistors are a lot smaller. So that blob of solder there is where I removed the resistor, and now the circuit actually has continuity when I push the button. So if I put my leads on here, on 3 and 4, now when I push the button, it's going to pass ground through it. Perfect. Also did the same thing for the driver's side. This one's not so pretty, so we're not going to show this on camera. While the blob was cooling, I pressed on it with my thumb and just smashed it. But it is secured on there. So now what I'm going to do is go ahead and get the new wiring and the new buttons onto the steering wheel. And then we can work on installing the clock spring and getting the wiring set. Like I said, this one here, these 3 wires, I'm just going to snip these. What I'm going to do is I'm going to have a ground, which I'm probably going to have from the CAN bus, which is going to be like a button ground, which will be active below a certain mile an hour, so I can't accidentally hit the trans brake while I'm driving. And then the other 2 will be inputs to the Holley. Alright, so we'll assemble the button. This is the driver's side on-off. These new rubber boots are really nice. So just slide back over. I can just press the board back on. Alright, so now the real test will be the buttons through the clock spring. So I have this wired up, plugged in here. I'm going to take these 3 wires that I was talking about before, the blue, yellow, and the green, and I'm going to cut these guys, and I'll strip them all back. Alright, so now I have one hooked up to the yellow, which is the brake out, and one hooked up to the blue, which is going to be the ground in. So that trans brake out works, and now I'll switch over to the bump button, and again connect to the blue, which is going to be the ground in. I hit my set accelerator button, and now my bump works. The guy got the stuff. The guy doing the things got the stuff. Okay, so I have this Hella solid state relay. And this is actually pretty easy to hook up, and I tested it, verified it. I want to show it to you. So 3-wire hookup. This is your 30 pin, which goes to 87, just like a normal relay. So this is like your source power, where your 12 volt is coming from. This one out is going to be going to the trans brake, and then I have a ground trigger. So the orientation is just like this, similar to a regular 4 or 5 pin relay. 30 and then 87. So I'll hook this back up and we'll test it. So right now, this is going to be more of an audible test than a visual test. So right now I have a relay here. I have one side grounded, and when I touch to 12 volts, I get the relay to turn on. So what I'm going to do now is I'm going to take my to the trans brake wire, 12 volt, and I'm going to hook that up to the relay, because that's what's going to be triggering the relay. So this one would be simulating going to the trans brake. This wire, pin 30, is going to be on a 12 volt source. And now what I'm going to do with my ground is I'm going to give that thing a ground, and now you can hear the relay clicking. So that relay is clicking, this one's not clicking. This is a solid state relay, but just wanted to do that so we can show that this thing is actually working with just the 3-wire hookup. So now I'll go ahead and hook this up in the truck. So this is going to go to a 12 volt source, this one is going to go to the trans brake, and then this one is going to come from the Holley with the staging output. So now I'll go ahead and hook this up in the truck. This one's going to go to 12 volt source, this one's going to go to the trans brake, And then this is going to be a ground output from the Holley, which is the staging output. All right, so under here, starting to look a little bit more straightforward. So we have one wire, this is the trans brake in, this is the bump in, and then this wire is going to be the button ground. So this one's going to input 1 on the Terminator, input 2, and then this output is coming from the CAN bus module. So I'm going to use that as my button ground, and then I can set parameter for that, like under 10 miles an hour, or whatever parameters I want so it doesn't activate while I'm driving. And then this one here is going to be the staging output that's coming from the Terminator. So I really just have the 3 wires left, the staging output and then the other 2 wires on the relay. Alright, I just kind of zipped through buttoning this stuff back up, not really a whole lot of excitement. I hooked up the 1 wire that I was talking about there, ran the 1 wire to the red trans brake wire that I had here, and then I just stuffed the relay in back here with my line log relay. So I do just still have the CAN bus module in here. This is the Boost Smart IO CAN bus expander IO module. So it adds 4 inputs and outputs, so that's where I have so many inputs and outputs now on a Terminator setup. So one thing I wanted to make sure I cover before, I mentioned that I was using the staging out from the Terminator, and then the button ground out was going to be coming from the CAN bus module. So I did that intentionally because the staging output has to be a fast reacting thing, and sometimes the CAN bus module can react a little bit slower. So I try to keep the less critical items on the CAN bus module, like I don't want to do bump or boost control or anything out of the CAN bus module, anything that has to like react fast. But the button ground, I'm not going to need that to work like within a half a second, so I keep it on there because it's going to be more of an on and an off, and I use the CAN bus module to add sensors and stuff like that. So just wanted to make sure I covered that. I intentionally set it up that way, and I left 1 ground out so that I could do the brake and bump with the staging output left on the Terminator. So all that's left now is to configure everything and set it all up. So I did go through when I was wiring it. I have on the CAN side, I have output 2 going to button ground. On the Terminator X side, I have input 1 on my brake, which is the same thing that it was set up on before, the brake and rev limiter, but now I'm adding the white-red wire for bump, and then I'm adding the output 3 for staging output. Okay, we're going to try this. Last time my screen recorder froze, so we're going to wish for the best on this one. So first thing I did, because my original trans brake setup was off of a positive input, so I want to go to rev limiter and then inputs, and then I changed my rev limiter 1 to a ground output. So you can toggle this back and forth between 12 volt and ground. I switched it back to a ground. Next thing I did was go into system ICF and then basic IO, and then I want to make sure that the staging is enabled. So click on staging, enable, and then I'm going to use duty cycle. You can pick fixed or duty cycle. And I'm going to start with 16 Hertz and 33%. I found this on a forum, and someone said that Cameron Vick uses these settings, and if you don't know Cameron Vick, look at the Cameron Vick YouTube channel. He's got a really awesome Crown Vic that runs 8s, and he uses a Jakes D3. And there was a post on a forum that said that he uses these settings, so I'm going to start there. And then that pretty much has me covered for the inputs. But output, I created this button ground output, which I don't really think I needed to do now because the software changed. So my original plan was to use this button ground so I could set parameters to be able to enable it. But now in the staging control, it has an advanced enable. So I could advanced enable and then set this to speed below 10 miles per hour. And that would do the same purpose as what I'm trying to do with the button ground. But I already have it wired like this, so I'm going to do it. And I have extra outputs right now that I'm not using, so I'm not too worried about it. But yeah, that secondary enable, I don't think never used to be there. That's the first time I've seen it. So I don't know if that came with the V3 or if it was earlier than that, but it's there now. So now I have the button ground configured on CAN ground. And then if I go into configure, I have this set up with 1 input trigger speed below 10 miles per hour. Anytime the speed is below 10 miles per hour, it will activate my button ground output. And that's what feeds my ground signal to my buttons as the source ground. So in the CAN setting, I'm using output 2, CAN ID 42 on CAN bus 1. And that should pretty much be that. So I'm going to save this, I'll load it, and then I'll test everything and make sure it works. All right, gentle tigers. We're going to turn this on, and I'll show you what I got. So surprisingly, I did have everything hooked up right the first time, and it all worked. But one issue that I did have was the CAN bus output 2 wasn't working. So it took me a little while to figure that out. So I had to kind of like unwire a bunch of stuff. So I undid the wiring back here to kind of trace where I was missing the ground, and then eventually trace it back to the CAN boy. And then what I did was in the tune, I enabled all of the outputs just for ground, and then I tested all of them. So 1, 3, and 4 work. 2 is the one I was using. That one doesn't work. So I have it set up on output 3 now, and I have on the dash I have a light for my button ground, staging input 1, staging input 2, and then staging output. So staging input is trans brake, staging input 2 is bump, and then staging output is supposed to light up when the signal goes out for the trans brake, but this one's not working for some reason. Check this out. Stock steering wheel, and you can hear the trans brake solenoid clicking, and you can see the light light up. And then when I hit the bump button, you can see it light up. Try to do both at the same time here. Brake, bump. Perfect. So that staging output bulb not working might be a V3 symptom, because watch this. I'll turn it off and turn it back on, and the top left bulb for the button ground is now going to be a needle gauge. So if I go back out and then I go back into dash 3, it turns back into a bulb again. But if I turn it off, turn it back on, it comes back as a needle gauge. So kind of a goofy little thing. I'm not going to use any of this anyways. I just set up this dash so I could test the inputs, and that's a pretty cool feature instead of having to use the laptop with the cord. So I normally just run it on this one here. So that's all in and working now. Looks nice. Looks just like factory. I got some nice fresh rubber buttons on there. Now I'll just have to go out and test it. The Jake's D3, that's always kind of an issue that you hear about, is like it doesn't bump consistently. And one of the things I noticed when I had it on the duty cycle setting was when I would put the brake on and I would bump it, sometimes it would click twice and sometimes it would click once. So I would say probably every like 5th time I would hit the button, I would hear 2 clicks, and then I would hear like click, 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 and then it would do a double click. So I don't know if that's just me hearing things funny or not, but that was on the duty cycle setting with the 16 hertz and 33%. So then I switched it back to the pulse width setting, or single pulse setting, and then at 0.075 or whatever, it would only do a single pulse. And then I changed it back to duty cycle, and it was doing like the random double pulse thing. So I'm just gonna have to go out and test it and see how it does and see where we end up. I don't usually bump into the beams very much anyways, so I'm not really super worried about it, but it would be nice to be able to have it work, and now I can test it and tweak it. So hopefully you guys enjoyed the video. This was kind of a long one and it was a little more technical, but just kind of wanted to show my thought process and walk through like how I would integrate something into the vehicle. So some of you guys probably think it's crazy and it's a waste of time, but it's something that I like enjoy doing. So, and it's a little challenging, rewarding in the end, and we got a cool product out of it. So thanks for watching. Have a good one. Hopefully you guys enjoyed it. And then maybe when we're done figuring out what we want to add to this thing, we can finally finalize the wiring. That might be a winter project. I still would like to maybe add transmission pressure and some other stuff. But after transmission pressure, I'm pretty much out of inputs. And then we're almost crossing into Dominator territory. So I don't know, guys.